let me start by observing that because you have come to this workshop, you probably already have some notion somewhere in your head that there's something secret somewhere in the ecosystem of your DApp, and you're trying to keep that secret across nodes within the politics of your distributed application. And that's, if that's true, that's great. Whether or not that's true, what I want to explore with you over the course of the next 25 minutes is, in addition to that, the how and why secrets exist in DApps in the first place. In other words, you don't have to identify as a security application or a privacy application as an application with sensitive data or in some sort of controversy wherein one party has to keep a secret as part of the essence of the app. That the kinds of secrets that you have in your DApp are not a function of the feature set of your DApp at all, but instead are sort of very rudimentary, mundane secrets, like wanting to be able to share keys, wanting to be able to share access to files that are, or maybe in-game elements if you happen to be building a game where the strategy is ruined if other characters don't know them. So the reason we call this workshop, the reason that we call the workshops that we do handling secrets in your DApp with NuCypher is because we are looking to serve DApps that are doing things that we haven't even thought about. And we think probably there are secrets to be handled in all kinds of distributed applications, not just the ones that maybe rush to our mind thinking about developing NuCypher. So with that in mind, my name's Justin. I'm in a school bus here in Portland, Oregon. I don't know if I'll give you a 4-second tour of my surroundings. This is my home, and I am surrounded by, you know, various distributed technology here and musical instruments. And I spend a lot of my days thinking about the ways in which we can bring cryptography, and particularly novel cryptographic primitives, to usability, and particularly mainstream usability for distributed applications. Give me just 1 minute here. I'm not super used to Zoom, the software here, and I'm often forgetting how to do. How do I share my screen? The green button? You're all still there, right? Yeah. I think I heard something like a yes. There we go. How's that? Can you all see that now? You see the NuCypher slide? I'm sorry, I know this is awkward. I'm just not very used to Zoom.
Yes, we do.
Yeah, great. I'm not gonna do a ton of slides. You know, decks are not my thing. I like to show code a lot more than I like to show a deck, but I do want to just walk you through a few things. So, you know, here's essentially our vision in NuCypher. We think privacy is a fundamental human right, and we build the tools that developers need to make privacy-preserving applications. And again, with the proviso that I just went through, that privacy-preserving applications don't need to be privacy-preserving applications as we know them. They also can be applications where privacy is only an issue sort of on the side as part of the mechanics rather than part of the feature set. And today, I'm going to talk to you about our initial tech offering, our Ursula character. And Ursula provides data privacy and access layer control for DApps and blockchains using threshold split key proxy re-encryption. At a high level, understand that what we do at NuCypher is we dredge the world of cryptographic primitives, particularly the academic papers from the past 20 years or so. When we find something that's interesting and that's never really made its way to the forefront, we ask ourselves, in a collusion-resistant Byzantine fault atmosphere like the blockchain, can this cryptographic primitive be useful in a way that it wasn't useful before? The answer for this particular cryptographic primitive, again, threshold, split key, proxy re-encryption, we believe is yes. And when we find the answer to be yes, we build a character that has the power of that cryptographic primitive. And when I say a character, I'm talking about a friend of Alice and Bob. You probably all know Alice and Bob. In the traditional public key infrastructure narrative, Alice sends a message to Bob using Bob's public key, and Bob can retrieve the message using his private key. So we've expanded this narrative of characters by thinking about beyond simple public key infrastructure. What happens when you have different characters interacting, each of whom has different powers? So for today, because we're going to talk about our proxy re-encryption offering, I want to talk to you about these 4 characters: Alice, Bob, Enrico, and Ursula. Alice is the authority. Alice decides who is and is not Bob. Alice makes a policy public key. Everybody that encrypts in the NuCypher cryptology, while the NuCypher proxy re-encryption cryptology encrypts not for Bob, not for the public key of an individual, but for the public key of a policy. Alice decides who can and cannot decrypt items that are encrypted with that policy public key. Okay, and then let's go down to Enrico in the lower left corner. Enrico is the encryptor. Enrico encrypts the data. Enrico just continues to dispassionately encrypt data for the policy public key. Enrico never knows who Bob is, never knows how many Bobs there are, doesn't know when Bob was granted access, whether Bob was revoked access. So Enrico just continues to encrypt for the policy public key in a totally permissionless way. Enrico has write permission, but not read permission from other Enricos. Bob, or we say Robert the Retriever, can retrieve secrets on the NuCypher network, but only those to which he's been granted access. And you could also subsequently say only those to which he's been granted access and not revoked. And then the interesting one in the lower right corner, Ursula. Ursula, the untrusted re-encryption proxy. Ursula is capable of re-encrypting data without ever seeing the plain text, from having been encrypted for the policy public key to being encrypted for Bob's private key. So only Bob, only all of the Bobs are able to decrypt data that's encrypted this way. Enrico encrypts for the policy public key. Ursula re-encrypts so that Bob can decrypt it with his private key. Okay, and this is just a very quick overview glance of proxy re-encryption. I'll give you about 20, not even 15 seconds to just sort of take in the directionality of this diagram, and then we'll walk through it. You see Ursula in the middle, kind of the star of the show. Alice gives we say RK there for re-key. Alice gives a piece of cryptographic material called a re-key to Ursula, actually to N Ursulas, because this is an M of N scheme, but that's not necessarily important for your hackathon this weekend, but we'd love to talk to you about it if you want to understand more of the mechanics. Then Ursula is able to take a secret and re-encrypt it for, here we show Bob and Charlie. Charlie is not a character in the NuCypher cryptology, is just, as often is the case, a word that we use for another Bob. You might imagine, for example, a decentralized Netflix. Okay, I don't want to get so deep into this because I don't want to prejudice what might be your use case, but you can go back through and watch this talk and take a look at the slide. It's pretty simple. Here's our website, our GitHub, our docs, and our Discord. We'd love to see and hear from you on our Discord. Let's see, at ETH Berlin just now, we did not get any solid submissions, and that made us sad. So if you are considering, if you're sitting in the room, you must be considering hacking. If that's the case, we are really hoping to get some interesting projects this time. Feel free to jump in the Discord, even if you don't want to, you end up not hacking, that's fine. We'd really love to talk about NuCypher and about what we think are interesting, not just interesting use cases, because that's your creative angle, but what we think are the interesting advantages of this proxy re-encryption offering over the public key infrastructure. Song of Storms has been on my mind a lot recently because, you know, the illustrious and highly effective leader of our state, I don't know if you heard this recently, drew with a Sharpie the path of the hurricane that he insisted was going to hit Alabama, modifying the path so that it would indeed hit Alabama. And there's something about that. It's sort of as arbitrary as making it rain by playing an ocarina, right? Except that this is a grown man. Okay. Let's look at some code. This is the fun part. You're all still with me there, right? Yeah, awesome. So $2,500 bounty for the coolest thing or things, you know, sometimes we divide it up, that are made with NuCypher. We have a few different ways that you can go about that. We have a browser extension that we're in the middle of rolling out right now. So if what you're making is browser-based, definitely hop on into our Discord and we will support you in getting the browser extension filled out. We have inter-process communications interface, you know, standard IPC interface if you're doing sort of get stuff. Oh, wait a minute, I forgot to switch. That's right. I need to do Zoom to switch you over to, you can't see my code, right? You still see the...
We do. We see your code.
Oh, you do?
Well, we did. Now we see you.
Ah. Let me get you over here. There, you see my pie chart now?
Yes.
Yeah, good. Okay, great. So, you know, the reason I bring up the bounty now is because we'd love to have people building on our new browser extension, and that lets you retrieve secrets. So you can like load a web page, and you can you know, click on something that is a NuCypher secret, which is to say encrypted by Enrico. And then you can load the web page as Bob, click on it, and then behind the scenes, it connects to the NuCypher network and retrieves that secret. And so that if that's your angle, we'd love to talk to you about hacking on that. We also have a IPC, standard inter-process communication. We have a JSON RPC endpoint, and then we also have probably our sort of cleanest and most feature-rich interface is the one I'm going to show you right now, which is our Python API. So here, we call this our Finnegan's Wake demo. We will re-encrypt one line at a time the James Joyce novel Finnegan's Wake. And we've just got sort of some boring setup stuff up here. So let's get down to here. Here's where, again, sort of the star of the show. Oh, I actually, you know what? I do want to mention to you, because I showed you that the chart there of the 4 characters. Are you still seeing my PyCharm, or do you see my browser?
PyCharm.
Okay. Am I the only one who doesn't like Zoom? Okay. Now you see, I wish I could see what you see on my screen. You know what I mean? Do you see my browser now?
Yes.
Yeah, okay. So this is this is just a screenshot from our ETH Denver. This is all on our YouTube. This is a screenshot from ETH Denver where I walked through the CLI interface. And as you can see there, I put Alice in one window, Bob in another, Enrico in another, and Ursula in another. So if you're thinking about hacking with NuCypher and you want to sort of dig down into the actual CLI commands, which gives you a really good overview of sort of which data is needed for each character, you might go back and watch this ETH Denver demo. And I just wanted to mention that because the little chart that I had in the slide is sort of the same shape there. And so here's a way that you can actually get a CLI view of that super simple chart on the slide. Okay, let's hop over to PyCharm now. And here, okay, so we've got, you all can see my PyCharm, right? I have a green box around it, so I assume that's a yes. Here's Ursula, the untrusted re-encryption proxy. In this particular Python module, what we're simulating here on line 47 is the existence of our test network. Now, in the real world, we have a test net running on Goerli that's been pretty solid, and we invite you to hack using that. You'll find that the documentation in our Hackathons channel of our Discord invites you to use that test net, and we can also help you to use that. It's actually super duper simple. to do the testnet that way. And that allows you to not even need to do anything comparable to what you see happening on line 47. But here, what I'm trying to show you is sort of the full gamut of how the Python API works to share these secrets. Here's some policy details. We're going to say, hey, 5 days from now is going to be our end time. Our M and N values are going to be 2 and 3, which means that Bob, Alice will give fragments of that rekey to 3 Ursulas, and Bob needs to visit any 2 of them. And so in a way, this is sort of reminiscent of Shamir's secret sharing, if you're familiar with that technology. But again, to be super clear, Ursula never sees the plain text. Neither those 2 Ursulas nor all 3, if they collude, are able to see the plain text. So it's different in that sense from Shamir's secret sharing. And here we have a label. We say secret files and stuff, and for these purposes, I've made it look like a file path, because I think that's sort of an interesting way to use the label. So shares are per label. Alice grants Bob on one label that doesn't give him access on another label. So thinking about it like a file path, this means that you can share one file path with Bob 1 and 2 and 5, and a different file path with Bob 2, 3, and 4, and so on. Here we have Alice. Okay, Alice takes network, REST middleware, domain, which we're actually deprecating now that our domains, I think, are probably just going to follow test nets. We say, oh, she already knows about Ursula. Again, in the real world, our test net serves there. And for the purposes of this demo, and perhaps if you're using a Python API and trying to sort of tune things, you can tell Alice whether to discover nodes on the same thread. That's an example of sort of the performance knobs that we have in the Python API that aren't available elsewhere. And here we say federated only, and federated only means that Alice doesn't have to pay, and the nodes are just sort of altruistic. That's not how it is in the real world. But if you want to run, if you want to grab our repo and run this particular demo, it's easier to run it this way, since you can run all the characters locally without needing a blockchain node. Now, Alice can get the public key even before creating the policy. In other words, before Alice has any notions of granting anybody access on the network, Alice can get the public key that all the data sources, again, whom we call Enrico, will need to use to encrypt. So here you see we get the public key by doing get policy encrypting key from label. Okay, and once again, that label, which is kind of like a file path, a different label will produce a different public key for the policy. And later we'll see Enrico use that. Here's Bob. Bob takes essentially all the same arguments as Alice. Nothing interesting there. Alice starts discovering the network in our CLI and JSON RPC and browser extension. This happens automatically, but in the Python API, you get to decide when the nodes start discovering each other, which is maybe useful. That's not an easy thing really to do via the CLI, because you have to sort of double dip. I don't know. We haven't found an interface that we love for that. And now Alice grants. This is sort of the first interesting thing. Alice grants access to Bob on the particular label for those values of M and N we had, and the policy expires at the policy end date time. 2 things I want to point out here at this line. The first thing is that it makes a network call, which does a whole bunch of interesting things. It goes out and sees which Ursulas are staking the NuCypher token in the proper amounts to be able to hold the policy. It finds N of them. It sends the kfrags out and gets receipt responses. So there's sort of a lot going on packed into this grant command, but we've tried to make it feel like it's just access management as you know it. The other interesting thing I think to point out here at this stage, now that we've gotten this far, is that Alice and Bob, these are actual classes in our code base, and we think that this is really an ideal way to abstract cryptographic primitives in a way to make them useful. And we'd love to hear from you about how we're doing in that respect. Here, and we have our lawful characters in character, or NuCypher characters lawful.py. We have here, you can see Alice and Bob and Ursula and Enrico are our 4 main lawful characters. Again, they each have different powers stemming from different cryptographic primitives. We also have unlawful characters. So we have sort of an alignment structure borrowed from classic tabletop role-playing games. Here we have Vladimir that serves as an unlawful Ursula. Vladimir tries to break the rules of the network in some either a selfish or destructive way. And so when we think of an attack that can be performed by one of our nodes, we put that attack here on this class. And so you can feel free to sort of read what this what this character is capable of doing and how we prevent those attacks on the network. That's something that, I think is really important for anybody that is ostensibly working on privacy tech. I think it's really important for them to wear on their sleeve how an attack works. And particularly, I think it's important to codify that attack in a way that mirrors the proper functionality of the network. In other words, this is essentially a mirror. This class is essentially a mirror of this class, Ursula, And so I think it's very important. It's something we're proud of, and we invite you to take as deep a dive as you like. So back to the narrative here. We've got Alice granting. We make a quick assertion. We show that the public key on the policy object is the same as the one that was returned here. Now Alice puts her public key somewhere for Bob to find later, right? Takes the bytes of her personal public key, which we call a stamp, and then we say she just disappears from the internet. Starting with line 92, you're going to see something that public key infrastructure cannot do, right? Think about this. If you're using public key infrastructure, the same party that has the secret, looking at the secret, ready to encrypt it for the recipient, they have to be online at the time that it's encrypted. Right here, we don't have that. The party that decides who gets the secret can leave, never to be seen again, and yet still, devices that are maybe under Alice's control, sometimes we imagine Alice controlling Enrico, sometimes not, can continue to encrypt for the policy. So here, line 95, some time passes. Little song of time to get our time passing. And now we have Bob doing sort of the interesting part. And say here on line 103, Bob the Biddler, because we imagine that what happens in the next few lines is sort of what happens in the internals of your app. This is the interesting part where your user gets a secret and can do something within the context of your distributed application. So the first thing we do here for Bob is we have him join the policy. This is another step that you'll see in the Python API that is not in the others. In the other APIs, Bob just retrieves, and it's sort of all in one step. But here we show the granularity of our Python API, breaking it down. Again, just to be clear, I'm talking up the Python API because we think it's cool. But our CLI interface, our IPC interface, our JSON RPC, our browser extension, they're also all fully featured. And we are happy to put development investment time into whichever one is gaining traction at a particular hackathon. So over the next couple days, if you are wanting other features built into those other interfaces that aren't there, let us know. We're constantly working on these things. We're really, really excited about each of the interfaces. But I'm showing you the one that's the most mature, of course. Okay, now that Bob has joined the policy, we're going to show how Enrico, the encryptor, can share data with the members of this policy and how Bob retrieves it. We say here we only read some lines in this demo. Yeah, it is limited to 25 lines because we were having people run this and, encrypting the whole book starts to get computationally expensive. When you run this demo, we only do 25 lines, but of course you can change that number. So here we're going to enumerate the entire book and iterate through it with each line as plain text. And we make a new Enrico each time. So in other words, the encryptor, you don't have to do that. You can use the same Enrico over and over again and check that signing key if the source is in some way important to you and represents some element of validity. But you don't need to. You can make a new one for every line. And here we encrypt the message and we leave the public key. And now we delete Enrico just like we deleted Alice. Now let's go back to Bob. Okay. Bob is going to reconstruct Enrico from its public keys. Again, just to show that what's happening here is we've deleted this object, but Bob can still reconstruct it. using the policy public key, which of course Bob needs, and using this is essentially the public part of its signing key, which we're trying to push the words verifying key for. And now Bob can retrieve the original message. So Bob somehow restores Alice's pub key from an ancient scroll, wherever, in your side channel of your app, you've got that. And then he gets the clear text by here bob.retrieve. And he gets the single passage here and asserts that indeed it is the same original plain text. And again, in the other than in the Python API, you only need to do bob.retrieve. You don't need to do the join policy step. That also means that you don't have as much control over when the network traffic happens. So, there you get a sense of the NuCypher narrative. We are just about out of time, so I'd love to quickly switch gears to questions. And if I may put a question to you, I'd love to hear what it is that if there's anything we can do in 30 seconds or less, what can we do to really get you hacking on NuCypher? We'd love for a cool project to come out of ETHBoston. Again, partly because we now have a browser extension, a CLI interface, the IPC, the JSON RPC, the Python API. We'd love to start seeing these get used now that they're really ready. NuCypher hasn't really been ready for the big time until recently. Now we have our Goerli testnet up, and we have these all of this tooling. So again, I'd love to hear questions from you, and I'd love to hear from you what we would need to do to get you hacking. Oh, I'm told we're actually out of time. I'm sorry, I went a little bit over. Please do hop into our Discord, discord.nucypher.com. Really look forward to talking to each of you, and we definitely will be around to support you hacking all weekend long. If you have any other questions, that's a great place to take them up. We also can switch over to do voice on Discord a little later if you like. But thank you very much for your time, and we look forward to seeing your projects. Again, $2,500 bounty for either the best one, or maybe we'll divide it across a couple if there are a couple good ones. So thank you.